Hi, I'm presenting 3D Compositional Zero-shot Learning with DeCompositional Consensus. I am Farjad, and this work was done with my amazing collaborators. We humans interact with the natural world around us consisting of objects with their parts. So a display consists of a display screen and a stand, and a keyboard consists of keys and the horizontal surface they lie on. In 3D Compositional Zero-shot Learning, we want to task a model that given an unseen object class, it should reuse the knowledge from seen classes to generate a segmentation mask in Compositional Zero-shot and a class prediction in Zero-shot. We propose a new benchmark for this task called Compositional-PartNet that we built upon the original PartNet dataset. We refine the segmentation label space of PartNet to allow overlap between object classes, and we divide the 24 object classes into 16 object classes that we use for training and 8 unseen object classes that we use for unseen generalization. The dataset looks something like this. So our unseen objects consist of bowl, dishwasher, door, and so on. And the dishwasher, for example, shares its labels with microwave, clock, table, and so on. And we want our models to realize this conditionality and use it for generalization. So if we just train a point net on this dataset and test the segmentation performance, we see that the model completely fails. So given the input of a dishwasher, the current segmentation model thinks that it's a storage compartment. And this failure is actually evident in other object classes as well. This highlights the need of building something new. This is where our novel model DeCompositional Consensus comes into play. The first part of our model consists of given an input point cloud X, the part segmentation function f generates multiple hypotheses. So the model essentially reasons that if this input is a laptop, I would segment it as something like this. And if it's a lamp, it would look something like this. The second part of our model uses the DeCompositional Consensus, the first part of which consists of hypothesis-driven part pooling. So given the segmentation hypothesis and the features, the model pools the point dimension of the features to get one descriptor for each part. These descriptors are used as input into a part scoring function G, and this function assigns a score of how likely is that this descriptor actually belongs to this part. The part scores are then averaged for our hypothesis to give a consensus score S representing the class. And we want the model to assign high scores to the valid hypothesis and low scores to the invalid one. So essentially, the model builds a hypothesis and then takes it apart into its parts as Lego blocks to see that if there is a consensus in this configuration. When we compare our model with baselines or segmentation performance, we see that DCC significantly outperforms all baselines to set a state of the art. Compared to direct segmentation, we see a 50% improvement from 20 IOU to 32.7 IOU. And we see that while direct segmentation fails on most unseen objects, our model is able to reason about 6 of the 8 unseen object classes. Surprisingly, we see that point capsule networks, which were inherently designed to be compositional, are not zero-shot compositional. When we compare the performance on generalized zero-shot classification, we see that DCC significantly outperforms the current zero-shot classification baselines from 2D to set a new state of the art. When we look at our results qualitatively, we see that while before direct segmentation completely failed, DCC is able to generate reasonable results for these inputs. So a dishwasher is now actually segmented as if it's a dishwasher, and similar results are observed on other objects. DCC is still not perfect, so we have 2 failure cases where DCC and all baselines fail completely on door and scissors. And when we study these failure cases, we realize that this failure case comes from our point cloud backbone. So even in the Oracle setting, the segmentation result is very unreasonable. So we need to address this as a community to build better point cloud models. To conclude, we propose a new task of part generalization beyond seen object classes called 3D Compositional Zero-shot Learning. We show that existing zero-shot learning methods do not utilize the 3D nature of the data. We propose DeCompositional Consensus to allow zero-shot conditionality in point cloud backbones. And we show that point cloud backbones have severe limitations when it comes to zero-shot conditionality, and we as a community need to address this. Thank you for your attention. We are very excited with what the community accomplished with this dataset. Our work is open source. Thank you.